I went to my first PASS summit. It'll be 11 years ago this fall. And getting involved in data community stuff changed my life. And I mean, I didn't really speak to or know a soul the first 2 or 3 years, but getting involved and helping organize things and getting into speaking and all that, it can change your personal life, professional life, everything. So strongly endorse, like, at whatever level you're comfortable getting involved, even if it's just going to local user groups and SQL Saturdays and all that. Please do it. It's awesome. Okay. We're here to talk about migrating your data to the cloud. So you may recognize these slides from PASS Summit 2023, because basically what we're doing is we're reprising our Cloud DBA fundamentals learning pathway from last fall. Obviously, with some updated information, things in the cloud do change. So some of these slides have had some tweaks since then as offerings have shifted. But yeah, a little bit more about me. I'm SQL at Speed everywhere online. So feel free to reach out after this. You can also reach out via email. So my work email address is on the last slide. My personal one is Matt, M-A-T-T, at SQL@speed.com. So feel free to reach out if there's questions we don't get to. If you want to talk about race cars, as the bullet says there, I do get to love talking about all that stuff. But what we're here to learn about is cloud migration things. I've done a lot of these projects. I was fortunate enough to co-write a book about them as well. So hopefully over the next hour or so, you're going to learn some things you don't know and things that'll help you. I know one thing that's interesting when I give sessions about this in person, I've been doing that for a few years, and I always ask at the start, raise your hand if you're in the middle of one of these projects now, and then raise your hand if you think you're going to be in the next year or so. And the number of hands that now go up for, hey, I'm going to be in one of these projects in the next year is the better part of every room I'm in. So I think this content is pretty helpful, and hopefully you'll think the same. So where are we going to start with this? So this seems silly, but we need to figure out what data we're actually migrating. And the reason I start there, and we'll talk about this as we move through these slides, these projects go well beyond a data team, but it's quite common in my experience for the data team to either be chosen to lead it or for the data team to be the first team approached and say, hey, we're going to migrate all of our servers to the cloud or all of our apps or a selection of apps or whatever. But they go to the data team first and they're like, your part seems hardest. We're going to let you kick that off. Now we need other teams and we'll talk a little bit later, what those teams are, what those people are, and why. But we need to start out with figuring out what data we're actually going to move. So let's chat through this here. There are obviously lots of types of data now. I kind of chose to go over these basic three. So number one is data warehouse data. Sorry, my dogs are going nuts. So if you can hear that, apologies. I start with data warehouse data because it box, and let's call that a traditional warehouse. And customers will say, we just want to lift and shift that to the cloud, like our data center's closing or whatever. Just want to move that. It's certainly possible, and we're going to talk later about how you can, but I want to specifically call this out up front. If your migration covers a lot of data warehouse type databases, it's a perfect opportunity to use the cloud to really reimagine what you can do. The things that the various data warehouse platforms in the cloud can do are generally far beyond what we can do on-prem. So instead of just saying, hey, I'm going to take what I've built over 5, 10 years, move it and leave it in the same state in exactly the same way for another 3, 5, 7 years, if you can, it's a good time to take that opportunity to say, you know what, Databricks, Fabric, things like that. Let's see what we can do that's different from what we've been able to do on-prem, and maybe a lift and shift migration isn't the most appropriate there. Could be, probably isn't. Unstructured and semi-structured data, it falls a little bit outside the scope of this talk, but I do want to chat just for a second about it, because it is a part of a lot of migrations. The comments I'll say here is that generally storage in the cloud is cheap. So if there's things you have to move, you're going to find a lot of inexpensive places to put them. If there are apps that interact with those, that conversation gets a little bit trickier. So because I say this kind of falls a little bit outside the scope of what we're here to talk about, if you have questions specifically about that, hit me up offline, and I'm more than happy to talk through those. Most of the focus of what we're going to talk about here is we're moving a lot of relational databases. That's generally most of the projects I do. That's the majority, sometimes the only thing data-wise that we're actually moving. So for the rest of this session, we're going to focus on that. So now we've talked through the types of data and maybe the different approaches and just some different things to think about. We're going to get to really what I think is the most important thing we have to know. So when a migration starts, we have to know why we're doing it. And that may seem counterintuitive. And at a big shop, you may say, well, I don't have a way to find that out. It's critical to find that out, or get as close to that knowledge as you possibly can. And here's why. I get questions almost every time I give a session like this. Somebody, maybe not in front of the room, but they'll pull me aside and say, okay, you talked about all the Azure SQL stuff, Amazon, blah, blah, blah. What's the best one? Like if I need to migrate a bunch of SQL Server data, what's the best cloud? What's the best platform, service tier, blah, 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 blah. And the answer is the classic, it depends, because there is no way to answer that without knowing what our end goal is. So these four are some of the most common ones I see. So we'll kind of walk through those, and I'll explain why that might, the decision here is going to govern every decision you make after this. So if your boss comes to you and says, okay, we're going to go to the cloud and we're going to save a bunch of money because I read on the back of a magazine in the airport that that's how that works. You're not magically going to save money going to the cloud. But if you know going in, well, my boss, his goal or the goal that's been handed to them is you have to save money, you're going to make different technical decisions after that. And that's where, and this is an ongoing conversation in a lot of ways, because you may come to them and say, okay, you say we need to save money, but you also say that there's basically no possibility for downtime in the environment at all. Here's what it costs to give you the SLAs and all those goals. That is not saving us money. That's actually probably costing a little bit more. So where does the compromise come in? And it may be that they say, oh my goodness, that's really expensive. You know, maybe an hour scheduled downtime a quarter is fine, or a month or something like that. And then you can maybe change your architecture, change the service tiers of the platform that you're on to save that money, understanding that there could be a bit of a compromise for uptime, for performance, things like that. That's one of the many reasons it's important to know why we're doing this, because you know it's one thing if two of us are just talking in a session like this and I say, well, you know, I don't know that there is a best one. It just kind of depends what you're after. A lot of times your boss, your manager, they're not going to tolerate that answer. They're going to say like, well, I need to know what the best one is. And it's perfectly okay to respond, well, I need to know what your end game is here. What's your goal? What are we driving at? So saving money is one I hear a lot. It's going to change a lot of the decisions you make as we move through this. The second most popular one I'll say that I hear is, okay, we're in some on-prem data centers and those are closing, or our board or our executives or whatever have made a decision to no longer be on-prem. So effectively we're closing our part of that. Those tend to have very hard end dates and generally a significant financial penalty if you miss it. So in that case, the goal may not be saving money. The goal may be pure speed. And one of the larger projects that I worked on, that's exactly what this was. I worked for a large company whose stuff you've definitely used, but you probably don't know it, and I can't say who it is. But they had data centers all over the world and grew by acquisition at a pretty high rate. So the data centers they had, they would buy some other place and then they would have more because they likely owned some stuff too. And they came to us and basically said, for budgetary reasons, stock price reasons, whatever, we're closing data centers in Amsterdam, in Hong Kong, in New York, and blah, 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 blah. Those data centers all have to be closed, or our assets have to be out of them by a firm date. If we miss that date, it's a millions of dollar thing, so you can't miss it. And their primary motivation was just speed. So what's the easiest, fastest way to get this stuff out? Obviously performance, like you have to maintain that level. They didn't care about saving money at all, because any kind of savings we made tweaking cloud stuff was absolutely dwarfed by the penalty if we didn't get the stuff out. So they're like, don't take any time to really make this any more financially efficient until we're done. So it's important to know that too, because you're going to make, you know, you may sit there and say, well, the best technical decision to support this app and all of its data and the thing that meshes best with your staff and all that is, Azure SQL database, let's say. But for whatever reason, maybe lifting and shifting a bunch of VMs to the cloud for them is actually faster. So is that where you'd want to go? Maybe not. Is that the most future-proof technical decision you can make? Definitely not. But it's the fastest and it meets that goal. So it's important here to know that. This third one is common. Like, you'll get a CTO that comes back from their quarterly CTO roundtable, golf game, whatever. They say, hey, we're moving to the cloud because all my friends are, and I don't want to get made fun of at the next one. That's a thing that happens. So it's important then to not let the conversation stop there. It's like, okay, we understand you don't want to get made fun of at the next thing, but really, what are you after here? Again, is it just pure speed? Like, we just want to be in the cloud to say we're there and kind of money's no object. That's never the case, even if a boss says it is, but let's just say it's true for now. If money's no object, there's certain approaches we're going to take versus, well, yeah, we're going to go to the cloud. I don't want to get made fun of at the next thing, but we have a budget of X, whatever that is. That's, that conversation can't just stop with we're going to the cloud. You have to get to the why. Last but not least, and I don't put this on here because I see this a lot, but I put this on here because I want people to know about it, because I feel like Microsoft's done a pretty poor job actually promoting that this is a thing. So I see this a lot in healthcare, where you're tasked with supporting a legacy environment that you're not allowed to move off of. And usually it's because hospitals and healthcare stuff is very risk averse for obvious reasons. People's lives are at stake. A lot of times they'll have this kind of risk assessment board or something like that that will certify the devices, hardware, software, like everything the organization can use. What can happen is you'll have a piece of software that's made on, let's say, an older version of SQL Server, runs on an older version of Windows Server. The vendor last certified that version that's now several years old. It's relied on for critical systems, and vendor went out of business 3 or 4 years ago. So the risk people will tell you, you can't touch that. That's the last version they certified. Sure, they're out of business, but we don't have a replacement for what this is, so you can't change it. But let's say concurrent with that, there's a heavy migration to the cloud going on, and you have to move that environment even though you're not allowed to change it. So one nice option can be Microsoft will give you 3 years of extended security support for free if you move that older environment into Azure as a VM. So like Windows Server 2012, its support ended last October. SQL Server 2012, its support ended 2 years ago this summer. You may sit there and say, well, I've got some SQL 2014 on-prem. Doesn't feel that old to me. And I'll say that doesn't feel that old to me because I used it a lot. Its end of life is July 9th this year. So if you're looking at environments that, again, 2014 doesn't seem that old, but you're like, well, I have to keep running this. I'm not allowed to upgrade it for whatever reason, but security is obviously important. I want to maintain support for as long as I can, even though the products are going end of life. Moving that VM or those VMs as is to Azure can be a really nice option, because Microsoft's still going to take care of you. Now, it's not out of the goodness of their heart. It's a carrot, so you are consuming more cloud stuff. But looking at it from a kind of a security and maintenance perspective, it's a really nice option for us to have it, instead of just saying, well, listen, we're stuck on prem because we have no other options. We do have an option, and it's got some nice benefits as well. Any questions or comments about that? All right, I'm going to take that as a no. So now we get to another very important part of this. Who do we need to do this work? So here's my first slide. Do you see data people anywhere on there? No. They're on the second slide, but they're not the first part of the second slide either. So networking people are key. And I could put an asterisk by this and say that's more relatable to a cloud migration that's absolutely from scratch. So you have no Azure footprint, you have no Amazon footprint, whatever. These first two then are absolutely essential. Because like I said, a lot of times people approach the data team for this, but we don't generally do this part. We don't generally set up the express route to Azure. We don't generally make sure that our Active Directory, Azure AD, Entra, whatever it's called now, we don't tend to wire that up and make sure that that's all synced, and make sure that everything we can authenticate to on-prem, when it's in the cloud, we can get into it, talk to it, do stuff to it, all of that. These are folks that do that. So if you were setting up cloud anything for the first time, these first two teams, people, groups, whatever, are absolutely critical. If you don't have those, if it's very small shop, then, and I'll say, like, I created these slides when I was not a consultant. I was in the middle of a very large project as a full-time employee. I would encourage you to bring in outside help, whether that's full-time employees, whether it's consultants, whatever. You want to make sure this part gets done right. And it's because of that third group there. So you obviously want to make sure you're able to maintain whatever performance you need in the cloud. You want to make sure you can do that securely. And if the networking bits are done wrong, a lot of assets in Azure, when you spin them up, including Azure SQL, is kind of by nature fairly open. It will have a public endpoint somewhere. Now, some of that is changing, but it's really easy to create a lot of insecure resources fast. And you may not realize you're doing it, because you may think, well, surely this defaults to be very safe, and then I have to open it up. Things like managed instance do. There's some other issues with it. We'll talk about those. But things like Azure SQL, when you provision them, they're maybe provisioned a little less securely than you might guess. Just not to say they're insecure, but that's why we want to have folks like this involved. We want to make sure that when we're spinning things up, the appropriate networking stuff has been done, so our database can talk to everything that it needs to talk to, and no bad actors can get to where it is. And generally that falls outside of the data team to do that, because that's not where our skills lie. Security people, so they're not just there to keep the data secure. And I've got a story about this. They can stop an entire project in it's tracks. So you may see that third bullet and be like, oh, my security team is such a pain. Like, I don't like dealing with them. They slow everything down. They're just a huge pain. It's their job to be a huge pain. But I was part of a project where, from the top down, so we were dealing with kind of vice presidents all the way down through team leads and worker bees. And it was, fairly large team on the client side. It was 4 consultants, me and 3 others from the place I worked at the time. We were traveling to their office regularly. It's an expensive project with a lot of people. And as we started to kick things off, we asked the same question we always do, like, where in the schedule do we bring your security team in? And they're like, oh, well, we have a workaround for that. Never believed that. So they thought basically they could get it rolling downhill far enough where it's like, listen, we've spent this much money, we've got this many people, you can't really stop it now. And it was because the security people reported to a different person than the group that we were working with, and all that kind of political stuff. But the security people actually basically killed the project we were on about halfway through, because as it was made known to them, they probably rightfully so said, listen, we don't have time to analyze this right now. You're at the back of our queue for that. That's going to take 2 to 3 months for us to get to you, and our review is going to take 60 days. And so the project essentially died. I don't believe they ever went back to it. I left the place shortly after that, but my teammates that were on that I still talk to, and they never really went back to finish it. So security people are important. Yes, they're a pain. It's their job. So we need to bring them in and make sure that they're a part of this as well. Another thing to keep in mind here. So you see we've gotten to the data people part of this, but let me kind of step outside these for a bit and talk about one thing it's really easy to lose sight of when you do a project like this. When you are migrating production environments to the cloud, there is always a period of time where you're essentially running in kind of a hybrid mode. You're going to have some stuff on-prem, you're going to have some stuff in the cloud. Some of that is going to be live in both spots. You are going to be asking a team that is probably stretched at this point to maintain the environment on-prem, keep it up, keep it live, keep it working well, all that. You're going to be asking them to do that for a complete other environment as well. It is perfectly okay to think about that as the project goes along and start the conversations very early about, do we have budget for extra employees? Do we have budget for contractors? Do we have budget for consultants? All of that. Because if you're taking a team that's, stretched to the max now to keep what you have running, you're then building more stuff somewhere else that's probably new to some of them. You're asking them to maintain that as a production ready environment as well. They're going to need help. I've been a part of a lot of these projects, and these projects eat people up. So however you choose to fill that gap, you'll know what's right for your business, right for your team, all that. But don't lose sight of that as we go through this, because basically from here, we're going to be talking tech for the rest of the time. But don't lose sight of the fact that there are people involved in this. They're going to be working weird hours as a part of this. A lot of this stuff gets done off hours, overnight, all that. They're going to be fried, and they're going to need help. So think about the best way for you, how you can help them, and don't lose sight of that as the project goes on. Because if you do, you'll get midway through the project, into the project, whatever, and you'll find that a good bit of your team is left. I've been part of more than one of these where even if the project met a successful conclusion, the vast majority of the team quits over the next few months because they were worked too hard. So be mindful of that. So back to the slide here. So you may wonder, like, why are app developers on here? So particularly if you're dealing with legacy home built apps, the team person, whoever that built that app, may not still work for you. Get as close to that person as you can, like whoever the last one was to maintain it, because every one of these projects I've been a part of, we had some home built apps where the databases were unique, let's say, and the database migration assistant, which we'll talk about later, would flag some stuff that said, listen, if you're going to move this to Azure SQL, to managed instance, to SQL 2022, whatever, there's some legacy code in here. There's some things that are going to break, some things that you're going to have to change. That's why we involve app devs, because there may need to be code changes for things to be moved to the cloud the way we want. Now, it's perfectly okay to say, okay, it runs on a couple of Windows VMs. We'll just lift and shift those. We'll run them as VMs in Azure. We'll make the changes to allow us to use Azure SQL or something like that later. That's okay. But we're going to have to involve app devs or app knowledgeable people at some point. Data people, we've talked about that. We're a critical piece of this, but all these other folks we need to almost have them involved before or at the same time as we get involved. These first 5 bullets here, really, that's what you need at the start of a project. And we did just talk about, Do you need help? And again, it's not a sales pitch. I do like my job. Centric's cool, but I've worked a lot of places. I've been on both ends of this. And like I said, these projects chew teams up. And we need to be mindful of that. We should be taking care of our folks, making sure they're in the best spot that they can be to be successful in their job. And these projects place some very unique stresses on teams and people and all of that. Any comments, questions about that before we talk about where our data is going and get into the nerd stuff?
So far, no question.
Okay, and I see at some point I've lost my subtitles. I have no idea why, but apologies for that. They're switched on. It just decided it didn't want to work. So, okay. All right, so let's talk about where our data is going. So there's some core questions we've got to ask about up front. Most importantly, which cloud? So there are three major ones. Azure, AWS, GCP, which is Google's cloud offering. There are others for sure. There are other private clouds and things like that. But if you look at market share and you look at offerings in the data space, which is most likely where our expertise is going to be needed, they're far and away the top three. So we're going to limit our chat and our scope to those top three. I will say if you get the opportunity to be a part of the discussion on which cloud you're going with, take advantage of that. We'll get into this in a couple slides, but not all the SQL Server offerings are the same from cloud to cloud. Like there are things you can do in certain types of Azure SQL that RDS can't do, some things like that. Understand the data you're moving, understand the architecture it needs to have, and that's really what we're going to spend the rest of the session on. And understand that while the clouds are very similar, there are some things that one can do that another can't do. And I actually talked to somebody at Past Summit after I gave this session at the Birds of a Feather lunch, which is basically you sit at a table and there's a topic and then people just come and sit down and talk about that. And he had come to this session. He then sat down and said, "Hey, I was notified that we've made a decision to use Amazon RDS for all of our essentially current on-prem SQL Server stuff. They had an amazingly complex replication topology, and what they were trying to do, kind of all the systems that they replicated data to, it was not possible to offer that same kind of service the way they were on-prem in RDS. But the people that made those decisions were not aware of that. And he found out too late. And so he's basically saying, what are my options? Well, at that point, there really aren't any. You're in a very tough spot, and you have to have a very tough talk then and say, hey, fancy people who made the decision on this probably signed a contract and spent a lot of money. We're going to have to change what it is we do to mesh with the cloud that you picked. So if you can be a part of these conversations, definitely do that. But I also understand sometimes, especially at larger firms, there are just relationships we can't do anything about. You're an Azure shop, you're an Amazon shop, whatever, and that's just what you're moving forward with. So you may say, well, this type of Azure SQL is just the very best thing for what I'm trying to do. But if you're on AWS, that doesn't matter. So be a part of this conversation if you can. If not, use resources like this session, like those of us that have done a lot of this, to kind of help guide you for the best landing spot in your cloud of choice. And in a couple of slides, we'll go over some of the basics there. Which type of service? So for data, we're basically looking at infrastructure as a service versus platform as a service. So IaaS versus PaaS. The next slide, I'm going to go over kind of what that means. So if you're sitting there saying like, I don't know what that means, in a slide, hopefully you will. But we do need to understand that there are those two types of data offerings, and there are significant differences between the two. So a lot of that matters, like what's the skill of your team, what's the size of your team, how much time do they have to work on stuff. That's going to govern this decision a bit as well. So if you don't have any idea what this means, here's the graph. So there is a pizza version of this, which is more entertaining, but I always feel like it's not cool to do that in a talk, especially at lunch. Hopefully you're sitting there having a nice lunch. But if not, I don't want you to look at my slide and be like, oh, I'm so hungry, I could go for a pizza. So I went with the boring one. So We won't worry about on-prem. That's off to our far left here, and I'm pointing at the screen, but you can't see that, so it doesn't help. On-prem, we manage everything. Cabling, racking, cooling, make sure things don't catch on fire, operating system, data, apps, all that. Software as a service, kind of beyond our scope here. We're going to focus on those middle two. So infrastructure as a service is most likely what a lot of us are running our databases on-prem. So those are VMs where we or some team of us manage the operating system up. So we are making sure that the OS is patched, that our database engine is patched, that our apps are secure and updated, and all those sorts of things. So basically, IaaS is a bunch of VMs. You can think of it like that. Platform as a service, you'll see that OS up to runtime is grayed out. Somebody else is managing that. So if you hear like Amazon RDS, Azure SQL, those types of things, those are platform as a service offerings. So we are managing our data. We're managing most likely the apps on top of that, but we are not going in and patching our deployment of Azure SQL or any of that. That's all being handled for us. So we're just caring for the data, the uptime, the management, the security, the patching, all of that is handled by somebody else, Microsoft, Amazon, whoever. So PaaS, you're not getting that for free. Those offerings do tend to be more expensive out of the box than IaaS, but you have to manage a lot less. So if you're looking at this and saying, wow, we are seriously understaffed, I don't have a bunch of people that can manage patching and all those sorts of things, okay, then PaaS might be a better offering, and it might be worth paying that little extra premium on top to not have to bring a bunch of people on. But there are trade-offs here. Cost, performance. A lot of the PaaS offerings can be pretty quick, but the performance you get out of a VM that you've provisioned and tuned to be blindingly fast is almost always going to be better than the fastest PaaS offering you can get. So if you're sitting there on-prem and saying, well, I work in an environment where execution time slowing by 1/10 of a second is a huge deal. It costs us money. Those PaaS offerings may not be the right thing for you. They're quickly catching up in that way, but you're probably going to want a VM that you've configured and tuned to be just really, really fast. Okay, so hopefully that's clear. If not, drop a question in the chat and we will talk about it in a few slides. So this next one is basically my attempt at kind of laying out what the equivalent offerings are across the clouds, and it's my kid's favorite professional slide of mine because I used emojis on a work slide. So they think that means I am with the times. So our left column here is Azure, middle column is AWS, Google is on our right. So if you're basically a VM in Azure, and we're looking at this from a database perspective, so this is a VM running SQL Server for most of us. The equivalent offering in AWS is EC2. So if you hear, VM on Azure, you can think EC2 in AWS. Google, though I'll be honest, this line can be a bit blurry with some of their offerings. Google Compute Engine is really their equivalent offering with like a VM that we're going to install SQL Server on ourselves and do all the patching and backups and all that stuff. When you talk about platform as a service offerings, that's our middle row here. So Azure SQL Database, this includes managed instance. I know that the naming can be a bit unclear, and I've had a few customers in the last 2 years say that, oh, we picked managed instance because it's the only managed SQL service in Azure. I totally understand where you get that based on the name, but all of Azure SQL Database is a PaaS offering. It's all managed. They just didn't put managed in the name of any of the rest of us. So if you're sitting out there saying, well, I thought I had to I had to manage Azure SQL myself because managed instance is the only one because it's in the name. Azure SQL, anything after that is a platform as a service offering, and it's managed. Amazon RDS is essentially the Amazon equivalent of most of those. Now, for every service tier of Azure SQL, there's not exactly an RDS offering that lines up perfectly. So we're talking more in concept here than like specific product lines. For Google, that's going to be Cloud SQL. Now, what those there's a variety here of what they support. So if you're sitting there saying, yeah, I've got a lot of SQL stuff, but I also have Postgres and MySQL and things like that. Keep an eye on the support for platform as a service offerings across the 3 clouds. It's pretty dynamic. And so if you're like, well, listen, this past stuff sounds amazing. I don't have enough people to manage all the stuff I have now, but I also have a bunch of database system X that's not SQL. Do some research up front to make sure that your intended cloud supports that. They don't all support the same things, and there is some shifts there. This third row, what I do want to go over is the migration tooling. So we're going to talk in a few slides about the different tools we use to do this. What I'm going to say, and hopefully the emojis make it clear, my kids say they do, but if not, the Azure migration tooling for me, so if you're going to migrate a bunch of data, a bunch of servers, whatever, the migration tooling in Azure for me is a little more mature and a little easier to use. The AWS stuff is fine, and there's not huge gaps in this stuff. It strikes me as a little less mature. The documentation gives us a little less, but it's okay. The GCP tooling, if you have a team that's very comfortable writing and running scripts, it's fine. A lot of the GCP migration tooling around data is script driven. It is very well documented, but there is not a friendly GUI for a lot of this. Now, can we assume that's going to change? Maybe. But for right now, if you have a team that's not comfortable writing and running a bunch of scripts, then you're going to want to be mindful of that as you select your cloud, because their migration experience in GCP is likely to be uncomfortable. And really the best way to sum all this up is, remember the team that you have involved here. Like what environments is your database team comfortable in? Do they do a lot of automation? Do they do none of it? Are they very experienced SQL folks? Are they not? Are they coming, like, are you an Azure shop through and through, and you're going to be able to get a bunch of good Azure data people to populate your new data team? Then yeah, Azure would be the obvious call there, but be mindful of the skills and experience of everybody that's going to be involved here. And if you're able to make the cloud decision, that's that's really almost the most important thing. All right, a couple of notes about AWS stuff. So like I said, RDS and Azure SQL are roughly equivalent offerings. There's not a straight kind of like for like with managed instance from Azure into AWS. RDS is quite similar in some ways. So you could say it almost straddles like Azure SQL database and managed instance, but it's not a 100% like for like. I also want to emphasize, so, and this probably doesn't suit everybody, but when we're talking about highly available setups in the cloud, we need to be talking about things across multiple regions. So if you go into Azure and you provision everything in US East, and US East has an issue, and we've seen a few of those over the years, they generally revolve around authentication. So it's not downtime like a data center exploded in a storm or something like that. It's something, generally a patch was rolled out or something, authentication goes down, so your data is still up, the services still say they're up, but we can't authenticate to it. So for us, it's down. You can mitigate that quite easily by having resources deployed across another region as well. RDS, depending on the document you read, cannot be multi-region. Now, when I presented this last November, the documentation was consistent and said that. I then talked to some people through the week that said, well, in certain scenarios, it can be multi-region, but it's not documented yet. As I was preparing to give this talk today, I went and kind of re-researched this to see what the latest was. And I'll be honest with you, the docs are in conflict here. The majority of them, especially the ones you would see, like if you just Google this, says that it's not a multi-region offering. There are a couple, I would say, less official docs, things on AWS blogs and stuff like that say, well, it can be multi-region in certain circumstances. So don't really have time to go into that a lot more here, but just be mindful of that. If you're like, well, I need a really highly available setup, we're going to spend all the money to make that happen. RDS may be challenging for you in that way. And for sure that the documentation is not well understood as far as what that means. The VM offerings are much more equal. Now, obviously, the one advantage Microsoft's always going to have when you're talking about SQL Server is they own Windows Server, they own SQL Server. So the teams working in Azure have access to the teams building the things, where the teams at Amazon that are building out EC2 offerings, it's more of a co-opetition thing. Like, obviously, they're working with Microsoft to make these products available. Do they have that direct line to the SQL Server bat phone? Probably not. All right, so let's say we chose Azure. So we've kind of talked about the three clouds. We're going to focus on Azure here for the last 20 minutes. So what are our options? So you might have kind of gathered this as I've talked through some stuff, but for data, really our three main offerings: SQL Server on Azure VM, Azure SQL Managed Instance, and Azure SQL Database. So Managed Instance is, I've had a challenging relationship with it. I'll be honest with you. I've been a part of some projects where it really caused us a lot of issues. If you run it very close to the maximum of its performance, we did experience a lot of issues with it failing over and things like that. The team has done a nice job and has resolved a lot of that, but it wouldn't be right of me to say, oh, it's amazing, because it hasn't always been. So VMs are probably, like I said, very similar to probably what you've got on-prem now. For managed instance, if you rely heavily on SQL Server agent jobs, if your database stuff has a lot of cross database queries, or you need the ability to set the time zone on your database offering, managed instance is where you need to be. So Azure SQL Database is a managed service, but you can't set its time zone. So like I consulted at a place where it had been founded in Central Time, and everything in the application, and it involved bills. So obviously time is very important. If a thing happens at 11:59 one day or 12:01 a.m. the next, it's going to be on one bill versus another bill. The whole app was hard coded to Central Time. Azure SQL Database runs in UTC, and they moved from on-prem to managed instance basically because it was going to take the devs 4 to 6 months to unhard code that Central Time link. So I always want to call that out, because managed instance is the only managed offering that you can set a time zone on. So let's go over the highlights of these. This, like I said, since it's most similar to what you have on-prem, this is likely the most comfortable move for a team that's new to the cloud. Like you could even, I would always recommend building a new box, but through Azure Migrate, you could just move a bunch of your SQL Server VMs into Azure and you're there. The team in the last couple years has done a really amazing job on the SQL Server IaaS agent. So on my resources slide at the end, I've got a link to kind of the team blog about what that means. But what it does is it brings you some of the managed capabilities that a PaaS offering would have to SQL Server on Azure VM. That in terms of kind of automated backups, automated patching, things like that. Team's done an awesome job. If I'm giving this session 2 years ago, I'm telling you, listen, you're gonna have to manage all this yourself, just like you do now. Now we're sitting here on, I think, April 10th, and that's not really the case anymore. They're going to hold your hand through some of this, and it's really, really cool. It's also, in terms of ease of migration, you have the most options landing on SQL Server on Azure VM versus the platform as a service offerings. Also, specifically, if you're running on VMware, you can still afford to do that, because unfortunately, their acquisition has not gone well for customers at all. But if you're running on VMware, there is specific tooling to migrate your VMware VMs and everything that lives on them to Azure VM as well. There is not that same stuff for Hyper-V. But if you're on Hyper-V, we can talk offline, because there's a whole host of other things we should chat about, but we don't have time here. So Azure SQL Managed Instance, what are our highlights here? So like I says, it's basically Enterprise Edition that's managed for you. So you're getting there's no limits on it. There is a storage limit right now, generally 16 terabytes. If you paid attention to the keynote announcements at SQL Bits, you'll know that for the general purpose service tier, which we'll talk about in a couple slides, that 16 terabyte storage limits now increased to 32 with what they call next gen GP. So there's that. This is also a managed way to get availability group architecture. So if you're running always on availability groups on-prem, and you want to maintain that for uptime and other things and go to the cloud, you can set up availability groups with a bunch of VMs. I've done it. There's a template in the marketplace for it. That said, I don't recommend necessarily that you do that because you're still having to manage the cluster and do all of that. Managed instance is built mostly on an availability group type architecture. So you're going to get all the benefits of that, but you don't have to manage the cluster. You don't have to worry about quorum. You don't have to worry about any of that. That's all going to get done for you. There are 2 service tiers here, and this is very similar to Azure SQL Database as well. So in general purpose means the storage is remote. So it's not living on the same box that everything else is. So you're introducing a little bit of latency to go get that data and bring it back. It's also why it costs a lot less. The data and log are on premium storage, but again, it's remote, so it's traversing a bit of a network to get to there. TempDB is still on local SSD, so you don't have to be sitting there thinking like, oh wow, it's going to be really slow because it's got to go over there to get TempDB. It does not. For business critical, it's a good bit more expensive. Like I said, it's basically an availability group underneath. General purpose is more similar to like a failover cluster instance. But BC means you're getting local SSDs for data and logs. So it's a good bit faster, but again, a good bit more expensive as well. I'm always going to recommend you test whatever target you pick, but especially for the general purpose offerings, because of the physical architecture we've just talked about, whether it's managed instance or SQL database, you're going to run into kind of physical performance limits for like log throughput and things like that. For the majority of customers, totally fine. For some edge cases, it's not. Let's talk through the highlights of Azure SQL database. So it's the widest array of service tiers. As we've talked about, it is a managed service despite it being left out of the name. If you're developing anything new in the cloud, for me, it's the wisest choice. So I said we're going to talk about service tiers and things like that. Let's dive into it. So DTU based, which is, I've got a link on my resources slide to what DTUs are. I also have a link to a video I did on the Data Exposed series a couple years ago, going into more depth here. So if you're curious about that and have about 10 minutes, you can go watch that. We don't have the time here to dive all the way into it. But this is basically kind of the original way that you provision Azure SQL Database. It's not going anywhere, but you're not seeing new offerings that use this. So basic is basically $4.99 a month. There are hard caps on size and things like that. But if you're looking for like a sandbox, like a development type thing, I would never recommend using this for production, but it is more robust than you'll think for that $5 a month cost. So definitely for the vast majority of projects, POCs, things like that, not a bad offering here at all. Standard and premium basically increase those caps. You're going to get more performance, more storage, all those sorts of things. But one thing with all the DTU-based offerings is I found they can be harder to explain to managers. It's like, well, I don't know what a DTU is, and Microsoft never really said. Like there were a couple great community articles that I linked to on my resources slides that were people's best attempt at explaining what a DTU is, but for manager types, they don't care, right? They're like, I don't know what a DTU is. I don't understand if I need 100, 500, whatever. They understand what I would say are the more updated offerings here. So when you provision things based on vCore, and if you go into the Azure portal after we're done here and you just type in Azure SQL into the search bar and say, I want to go make one, you'll see why I've laid these slides out like this. It's going to start you here on kind of the left side of the page, and then you go into the vCore based offerings. So this is there's much more that we could talk about here. In general, we've got the same 2 service tiers here, like we talked about with managed instance. There are architectural differences. Business critical is always faster, but always much more expensive. Hyperscale for me, so this pricing was updated in mid-December last year, and the price was actually cut. So hyperscale originally, and you might be able to guess this by the name, it was the highest capacity offering there was. So you had customers that are like, listen, I've got a 50 terabyte database on-prem. MIs are limited to 16. Azure SQL's got a variety of limits depending on service tier. I can't move this to the cloud except on a VM, and I don't want to do that. Hyperscale, its cap is 100 terabytes. So for a very large database on-prem, you then had a place to put it. But what I always thought was interesting about hyperscale is that the storage architecture is completely different, and struck me as honestly much more sensible because they kind of reimagined maybe what a SQL server should look like. And we won't have time to go into it here, but I'm happy to chat about it offline. It's pretty dry, but I think it's cool stuff because I'm a nerd. Hyperscale's a really compelling offering right now. So unless you specifically need serverless, so there is an offering of Azure SQL that's serverless. Now the name is dumb. There are definitely servers back there, but it's architected in such a way to handle a workload that's very bursty. So it's like, let's say you run a website and on Sundays you sell all the things you make that one day, and the other 6 days of the week people don't buy much of it for whatever reason. Serverless, you can configure and say, on my low, the lowest of the lows, I only need so much horsepower. On my busy day, I need a ceiling of here. It will then go get that. So as the workload starts to scale up, it'll say, okay, we're not at the low point anymore. I need to go get more stuff. It'll pull those resources in. It will then hand them back as things start to ramp down. Unless you're in an architecture like that, I would strongly recommend looking at hyperscale for any new development you're doing, because the log throughput is so much better than a lot of the other offerings. So again, we can talk more about that offline, but hyperscale is really cool. And it's definitely gaining a much bigger footprint than it's had, and I think that's wise. So how do you pick that stuff? So again, that was kind of a crash course through what a lot of these offerings are. How do you select the right one? So we need to understand what our RTO and RPO is. So that's basically how much data in time can I lose? So is it okay to lose the last 1 minute of data, 5 minutes, 30 minutes, hours, days, whatever? And then, basically when can I, at what point can I go back to? So you need to understand what the SLAs are around the environment that you're supporting. Can you have an hour downtime? Can you lose an hour data? Is that a minute? Is that a second? Whatever. We may need those really expensive and really fast offerings to get all of what we're being asked to provide for there. We also need to understand our budget, very, very much so. You may have gone through that. So, wow, business critical sounds awesome. Like, I think I need a managed instance and I need that, and I get a secondary replica that I can read, and like, that's what I need. It's awesome. And then you go look at the price tag and you're like, oh, well, my budget is less than that. So we need to know that budget up front as well. And this is where, like I said earlier, it's a constant conversation between management and you. Understand what their goals are. You tell them what it costs to meet those goals, and then hopefully there's some give and take there in terms of what we're able to pull off for them. The database migration assistant. So if you Google that, Bing that, whatever, it's a downloadable tool from Microsoft. It will analyze your databases for you. I have a link on the resources slide for how to do that at scale. So if you go download this after I'm done, you're going to see like it's a decent GUI, and you can connect to a server and analyze the databases there. But you may be thinking like, hey, Matt, I have an estate where I run 5,000 of these. Like, I can't pull all of them into a GUI. That's true. So they do have some things behind the scenes where you can run this at scale using PowerShell. I'm not a PowerShell whiz by any stretch, but the documentation is good enough where I've been able to do it over the years. So I would encourage you to look at that if you're needing to run this at scale. But any database you're trying to migrate to VMs, to managed instance, whatever, run it through the DMA, because it's going to tell you what will break, what you need to change, what's not supported on whatever offering you're going to go to, and it's going to recommend what you can do to get there without breaking stuff. Definitely test. Please test. I probably haven't said that enough in this hour. Don't just assume it will work. I've been a part of migrations where somebody will go read the current blog, and they'll say, well, I think Azure SQL Database general purpose, like that's fine. It says log throughput is whatever it is, and it says that's equivalent to this many IOPS, and I did a little bit of math, and that's fine for us, and we don't need to test. Always test, because remember, especially with that general purpose type architecture, there's latency in your storage that you're not dealing with on-prem most likely, or the latency you have on-prem is different. So definitely test. One of the great things about the cloud is we can pretty much fix any issue we have with a bunch of money. That will always get blamed on the data team at some point, even if you're looked at as the hero. Like, let's say something got migrated, the performance is really slow, you get approval from your boss, you go scale it up, you give it a bunch more CPU, all that stuff. And it's like, oh, the data team's amazing. In 5 minutes, they fixed all this. But maybe you've quadrupled your cost. I've certainly been a part of efforts like that. It becomes very difficult to go back because people get really used to it running with that increased speed. They're not the ones that pay the bill, but the data team almost always gets blamed for that at some point. So make sure you've baselined your environment on-prem. You know how your workload needs to behave now, and make sure you have some sort of monitoring tool that is going to tell you that in the cloud as well. So, and obviously we don't have time to go into all the different monitoring tool offerings and all of that. But one thing to be mindful of as you approach a data migration project is make sure that the tool that you have can monitor both your on-prem assets and your cloud assets as well, because you're going to need a way to kind of make sure that there's equivalent performance in both spots, and that's infinitely easier if the same tool can do all that for you. And I certainly have my thoughts on what the better and worse tools are out there. Probably not appropriate to discuss them in this venue, but if you're curious for my thoughts, reach out offline and I'm happy to share those. We talked about database migration assistant a couple slides ago. There is, and you're starting to see this in different parts of the other migration tools and the portal as well. DMA, if you're completely lost with everything I've just said, and you're like, there's so much Azure SQL stuff, I can't keep track of it all. I don't know what I need. DMA will recommend a SKU. You can say, listen, I have this database that I'm going to point you to, and I want to put it on a VM, but I have no idea what any of the VMs mean. I don't know what the classes mean. It's a bunch of letters, makes no sense to me. It will say, based on the database you've shown me and based on the workload snippet that you've uploaded to me, you're going to need this type of a VM with this much RAM, this much CPU, and all of that.
Hey,
So
Matt, so
yes.
we are at the top of the hour. It's 1 o'clock, so I think let's wrap up.
Yes. Okay. Yeah, I thought so. I was thinking I had 3 minutes left, but I can. Yeah. So if you need me to, I can jump right to the end here. So test. If you need to test for free, that last bullet is something there. How are we migrating? So there's a variety of offerings, like the AWS official offerings are AWS DMS. Backup and restore is always an option, but it takes a lot of downtime as well because you need to cut off access, take the backup, restore it, turn it back on. Another caveat here, RDS does not support databases older than SQL 2014. In terms of migrating to Azure, there's a ton of options here. I won't read through all of them. For VMs, every way you can move data on-prem, you can move in the cloud as well. If you're using Azure Data Studio or you're not, check into it, it's cool. There's a migration extension, which is basically a nice GUI experience to migrate databases. Definitely check into that. There's a lot of development resources going into that. Let's talk a little bit more about that quick. Here are the different options that it can do. Again, you've got to have Azure Data Studio. But it's in easy download, it's free, no worries. You can do both offline and online migrations as well. So depending on those SLAs and the goals you need to meet and all that, you can do that. Remember, like I said, these aren't just technical. You're asking people to work a couple jobs, put time in the schedule for them to recover, to rest. If the timelines are unreasonable, advocate for you and your team. People leave jobs because of these, and you don't want to be part of a project that does that. Few more tech tips. Make sure the code is as optimized as it can be before you move it. Like I said, cloud costs get hung on the data team all the time. Be very vocal if there are opportunities for the devs to speed things up, because that means you will spend less money in the cloud, and that's generally better for everybody. Like I said, here's a long list of resources, everything I've talked about when I referred to the slides at the end. Here they are. This is all the different ways to find me. And like I said, my personal email, if you don't want to email me at work, is matt@sqlatspeed.com. My clock says 1 hour and 7 seconds, so I think I'm done.
Okay, great presentation. Thank you so much, Matt. It's a great framework for migrating the data to cloud, and I'm sure everybody would have got a lot of information they were looking for. There are so many thank yous, and with that, let's wrap it up because it's a weekday, and this recording would be uploaded. So if you have like more questions, you have the Matt's contact information. So thank you so much. Thanks everyone for your time. Thanks, Matt, again. Bye.